Hello SpaceX, my name is Cleiton Soares and I am a mechanical engineering student at Federal University of Uberlândia in Brazil. Currently I am studying abroad at Oregon State University for 1 year with full scholarship considered by the government for high achievement students. I decided making this video because I want to show you how my qualifications match with the responsibilities required for the position of maintenance engineering at SpaceX Rock Development and Test Facility at McGregor, Texas for the summer of 2016. I hope you enjoy.
I participated in a lot of projects that might be of your interest. One of the most relevant was the ASME Student Design Competition last year. From an initial concept sketch, our team constructed a 3D representation of the machine in SolidWorks, which helped us to generate layout drawing to manufacture some parts at the machine shop. The machine pulls a projectile from a standard sheet of paper and propels it using compressed air. In order to automate the machine, we learned how to use Arduino and developed a relatively simple circuit with an electric board and a relay switch module. All this process was documented in a final report which includes the project planning, house of quality, discussion on customers, conceptual design, product design, mathematical analysis and test reports, drawings, Gantt chart, and etc. Please find it attached in my application. I would like to show you quickly another project that I developed for my fluids mechanicals final project. This work describes and makes the differential and analytical modeling of the Stirling engine. Its working principle is based on a thermal cycle that approaches the Carnot cycle, which establishes the maximum theoretical limit of efficiency of thermal machines. For ease of calculation, some assumptions were made for modeling the velocity of the gas, the volumetric mass, and the temperature. With the development of work and from results, we found out that, as in theory, the cycle behaved as an ideal cycle. One of the major problems faced was the difficulty of solving analytically the differential equations that were so big that MATLAB couldn't help. In order to approximate the solutions, we applied the explicit Runge-Kutta method that gave us expected results. We set up input values for the fluid as an ideal gas air with its properties. We plotted graphs such as pressure versus volume versus time, and force versus time. This study is an important part of a completely bigger project, that is, optimizing the dimensions of connecting rods. One of the most challenging codes I did was for a numerical analysis professor in Brazil. The challenge was to evaluate numerically the volume of a three-dimensional data set. It is known that MATLAB already has a function to do this job. It is the Quad2D, but it needs a defined function as an input. So you need to primarily fit this data into an approximate function, which MATLAB also has a function. The problem itself was to code in C all those functions using the lowest computational cost. Well, I implemented the general Taylor series to fit the data into a polynomial surface of degree n in both x and y. In order to solve the system of linear equations, I implemented householder transformations to perform key R decompositions and three diagonalizations. Finally, I used the trapezoidal and Simpson's rule to numerically approximate the double integral, and the results were very satisfactory as the more you increase the degree of the polynomial surface. It was amazing. But what I think it will mostly differ me from the other applicants is that my father owns a machine shop that is known as one of the most reliable industrial maintenance companies in Uberlândia, my city. It supplies clients such as Cargill, JBS, ADM, and other industries. And when I was in Brazil, I worked with him and learned a lot about maintenance. And I also had some experience with the ERP system of this firm. One day in the future, I expect to carry on his firm and apply all my knowledge and experience to do better for my community in Brazil. At least I could help my father in developing his project for a handicap pool lift share when I go back to Brazil. If you want to have a more diverse workplace and also a hard work, motivated intern, consider me as a serious candidate. Do not hesitate in contacting me. Thank you for your time watching this video and have a great day.